In previous tutorials, we talked about a flame system and that it could be used in Zelda-like puzzles. In the meantime, I updated the project using new assets from Kay Lousberg. You can find the links in the description. They look great and there's plenty of objects that can be used for these mechanics. This time I am going to show you how I implemented the trigger system. I decided to make it flexible so that it can be easily used from the scene 3 without messing around with code. As you can see, we have a door that we want to open. We have a few wall torches as children. If we select the door, we can see from the inspector that we have a custom variable called type. We can select a few options, or it will open the door when any one of the torches is on, and it will open the door when all the torches are on. Sequence, it will open the door when all the torches are turned on in the right sequence, the one defined in the scene 3 from top to bottom. If we pick the wrong order, it will reset the torches to allow fast retry. Now let's check the nodes. Door is a static body but with a spatial as root to manage the offset for rotation. We have a collision shape and an animation with open and close animations. If we check its script, we can see it extends a class named Triggerable, and the only other notable method is functEffect that plays different animations according to the input parameter. Torch wall is another static body, but with a burnable node inside. If we check its script, we can see it extends Triggerable too. We still have an effect function that is used to turn off the flame when a negative parameter is passed. Then we have a couple of callbacks that are connected to burnable signals, and as you can see, they call a setActive function when the flame starts and ends. Now let's check how Triggerable is implemented. We have a class name, Triggerable, a signal named triggered with a parameter that will bring the new state, a type enumeration, that's the one we use for the options, where we can see also the leaf and the note options. We store the node state in a boolean called _active. Please note that in this case we don't use setters and getters as the behavior is different for each type of triggerable. And then we have two arrays, one for sub-triggers and the other one to store activation sequence. In init, we simply add the object to triggerable group. We could do this in the inspector, but if we do this in code, we will never forget it. In ready, we build a list of all triggerable children. We store them in our array and we connect their triggered signal. Please note, beside the signal name, the object, and the func name, we also pass an array with the size of sub-triggers before updating it. This is in fact the index that the node will have in sub-triggers array, and we will use it for sequence type. Then we have an empty effect to be used in extending objects like doors and torches, as we have already seen. We have the sub-trigger updated callback. At the beginning, we have a special check for sequence. Let's set that apart as we will check it later. We store a variable isActive by using GetActive function. As you can imagine, the passed boolean is not enough to determine the current value, as we have to check all sub-triggers and the type of current node. The value is used to update current state using setActive. Trigger reset is another function exclusive of sequence type, and we will check it later. SetActive is basically a setter for _active. It first checks if the new value is actually different from the previous one. Then it calls effect function, and finally it emits a signal with its new value, in case current node is a children of another triggerable node. GetActive is the function that implements all various type differences. First of all, we have a check if current node is not a leaf and there's no children. In that case, we return false. Then we set false as starting value for result, and using match we go through all possible types. For leaves, we simply read the _active state. In not, we get the value of the first sub-trigger. There should be just one, but just in case we picked the first one, and invert its value using exclamation mark. In OR, we already have res as false, that's the neutral value for OR operator, and then we simply iterate through all sub-triggers and apply OR operator between previous result and current trigger. And type is quite similar. We alter the starting value to true as it's the neutral for AND operation, and then we iterate in a similar fashion, but this time we apply AND operator. As you can see, AND section is also used for sequence type. This is because sequence is a sort of extension of AND. It needs all triggers to be active first. Then we use continue to fall through other options, and if we are indeed in a sequence node, we will process the next step. After checking AND condition, sequence uses another AND between previous result and a comparison between current sequence and correct one. The correct sequence is always defined by the order of children in the scene tree. Top one is the first and so on. So we don't need to type anything. Range takes the size of sub-triggers and automatically creates a comparison array. Then we use result to call a reset trigger function. Let's go back to sub-trigger updated callback and see how sequence is captured. We expand the ifs body and we see that when value is false, it means trigger is off. It is useful for timed triggers like our torches that will automatically burn off after some time, or in case the sequence is longer than the correct one. The registered sequence is reset to empty. Then, if value is true, we append to sequence the index of triggered element, the index we connected before using the extra array for the callback. Do you remember? Finally, we check trigger reset. This function gets the final state of sequence as input parameter and checks it along with the length of current sequence. If sequence is complete but wrong, it resets all sub-triggers by calling setActive as false. But first it waits a few seconds so that the player can understand something was wrong. This could be replaced with some visual or sound cue to make it even more understandable. And here we are. We have a basic trigger system that we can expand with new type of triggers and effects. I hope you liked this video. If you have any feedbacks or comments, please feel free to post in the comment section. That would help me staying motivated. Thank you very much and see you next time.